looking at higher order partial derivative. The first one, we have f subscript x as the first order. Then you do it again. And the second order, and this will be f subscript x in form of subscripts. Then you can also have it in form of fraction, in form of fraction notation. That means you have your the first order differential. Okay, that's a partial differential of f respect to x, which is del f del x. You differentiate it again in respect to what? To x, and that will give you this. Okay. Then you can also have first order partial derivative that has been differentiated to this is f subscript x. Okay, and then this function treat it again respect to y, and that will give you f subscript x. So in fraction notation, you have del f del x, then you differentiate it respect to y. Then you have this. Another one of the second order partial derivative, you have your first order del f del y. So this function is differentiated respect to y, and then second time respect to what? Respect to x. So that's the second order partial, and that will be del square f, okay, del x del y. We have the fraction notation del f del y. Okay, that's a first order partial derivative. So this is respect to y, and then you do it again respect to y, and that's giving you what? It's giving you del square f del y square. Okay, so one thing about these subscripts notation is that you start from your left. We have f subscripts x. You start from the left, you differentiate the first one respect to x, and then again. In this case now, I said you start from left. That means you start from here, get your f subscript x, then after that you differentiate again respect to y. For this one, f subscript yx, you differentiate respect to y. That's the first one, partial derivative respect to y, and then again respect to x. So for the subscripting notation, you start from left to right. For the fraction notation, you start from right to the left. What does that mean? Look at this one, for example, now. The square f, the y, the x. So if you want to do this one now, you first of all do your the f del x. That's the first one. Then after that, you now differentiate this function respect to what? Respect to y. Now, fraction notation, you start from right to left. Subscripting notation, you start from what? From left to right. Let me also buttress more on this third one. Okay, so you have del square f, del x, del y. So it's very simple. You start from what? From right, you get your del f, del y, and then you differentiate that respect to what? Respect to x for this one. For Claro notation, this and this are equal. I mean, the second and the third one, they are equal. Let's quickly go to the third order partial derivative. There's nothing much there. What I would just say is that fraction notation, we start from what? From right to left. Okay, you do your del f respect to x. Okay, then respect to y, then respect to x. Okay, so that starts on the third order partial derivative. What I mean is that for this case now, you first of all do del f del x, then followed by what? Del y, making your second order. Then you do it again, del x. So that's what I mean from right to left. Okay. But for the subscripting notation, you start from what? From left to right. Okay. So we can extend Claro theorem to the third order partial derivative. This one. this one, they are equal.